Now we start with the capture technologies. There are like different capture technology that enable us to capture CO2. The first one is the way they call direct air capture. Direct air capture is a technology that removes carbon dioxide from the atmosphere directly. This graph can help you to understand the process of the direct air capture. So how does it work? By using high-powered fan, air is drawn into a processing facility where the CO2 is separated through a series of chemical reactions. Then the CO2 is either permanently stored in underground reservoirs through secure geological sequestration, or is used to make new products such as building materials and low carbon fuels. Second technologies of capturing CO2 is called post-combustions. Post-combustion CO2 can be captured from the exhaust of a combustion process by absorbing it in a suitable solvent. The absorbed CO2 is liberated from the solvent and then is compressed for transportation and storage. Certain solvent absorption processes are technically mature. The potential for emission reduction depends on the CO2 capture ratio, which is CCR, and the amount of heat or power required to drive the capture process. Now we come to the third technologies to capture CO2. It's called the pre-combustions. So pre-combustions capture refers to removing CO2 from fossil fuels before combustion is completed. For example, this graph can show you the process of the pre-combustions. So, for example, in gasification process, the feedstock, such as coal, is partially oxidized in steam and oxygen under high temperature to form what they call syngas. So this syngas is a mixture of hydrogen, carbon monoxide, CO2, and a smaller amount of methane. The syngas can then undergo the water-gas shift reaction to convert CO and water to CO2 and H2, producing a pure H2 and CO2 rich gas mixtures. And then the oxy-fuel combustions is the fourth technology to capture CO2. Oxy-fuel combustions is regarded as one of the most promising carbon capture technologies to mitigate the climate change, which has been studied and demonstrated in academia and industry as well. It relies on the fuel combustions of fossil fuels and oxygen separated from the air to obtain CO2 and water vapor. Subsequently, CO2 and water vapor are separated by condensation and captured CO2 is stored, and the captured CO2 is stored. Then the last technologies of capturing CO2 is called chemical looping combustions. It's a form of oxy-fuel combustions in which oxygen is introduced to the combustion reactor, not as a gas, via a metal oxide carrier, which is either fully or partially reduced in the combustion reaction.